Hello guys. So today I came again with a problem. So the problem is like how to protect your home appliances from getting damaged with high and low voltage. We know like in India we have high voltage and low voltage problems. Voltage fluctuations are very common in every cities of India. But yet we are dealing with it. Most of us we use stabilizers, but still our appliances get damaged. The point is, we do not use stabilizer for all the appliances at home. Everybody will agree, right? So, does anyone use stabilizer for a geyser? Just give a thought. I guess the answer is no. Similarly, do we use stabilizer for electric kettle? No. But why? Like these induction stove, mixer, grinder, chimney, RO, water purifier, etc. We do not use stabilizer. But the point is why? We know there is a stabilizer concept, it regulates the voltage, but still we are not using it. Then why are we taking such a great risk and not protecting them? This is a basic question everybody asks. Like, or nobody has given a thought of also. Now the question is, like, if this is the scenario, then definitely we should think on this, because means aren't these devices costly? Yes, they are. They are costly. Like we know a purifier comes for 18,000 rupees. Our induction ovens comes for 3,000 rupees. These devices are costly. And then why are we taking such a great risk and exposing them to high voltage and low voltage or voltage fluctuations? Definitely these devices would get damaged. But definitely this is a big problem that we are facing. And we cannot to have afford to have stabilizer for all the devices, right? That is also a point everybody would say. Like, are we going to keep a stabilizer for a fridge, for a TV, a separate stabilizer for a microwave oven, a stabilizer for mixer grinder? No, that will consume huge space. This is the main problem. Is it feasible that you have a stabilizer for all the appliances that you use? No, we cannot have stabilizer for all the devices that we use. Stabilizers, the because the main problem is stabilizers consume more space, a lot of space, and is costly as well. So for example, in minimum a person having will have definitely 15 to 20 such appliances at home. It is very common that today in a house we are living, we have two bathrooms, two geysers, there will be a mixer grinder, there will be a chimney, there will be a microwave oven, there will be a fridge, there will be a TV, n number of appliances are there, and you cannot afford to have so many stabilizers for each of them. I guess you all will agree on this ground. Now the question is, if we are not having stabilizer for each of the devices, then how do we protect them? People say, I have a stabilizer for fridge. Fine, your fridge is protected. I have a stabilizer for TV. Your TV is protected. Do you have a stabilizer for your mixer grinder? No. So that means you are at a risk for your mixer grinder. Yes. So then what is the solution to the problem? That is the biggest thing. Like everybody, we all know, like, yes, voltage fluctuations are there. We do not use stabilizer for all the appliances. Then what is the solution to this problem? So today in this video, I will give you a solution. This particular video gives you the solution. Please watch it, understand it. Definitely you will save a lot of money from your devices getting burnt and repairing them. So now the question is like from where you should buy it. So I always prefer Amazon for buying such items because like that it provides you hassle-free returns and all those things. So there are multiple variants for such devices. What you simply need to do is search for voltage protector. So there are many range of devices. I'll just give you a brief understanding. So this particular device that you see, so this is a very simple one. So this is just a over voltage, under voltage protector. So you cannot adjust the voltages. You see, it is a automatic over voltage protection. If you see in the description, so you cannot adjust the voltages. So similarly, you have a different variety. So this also you can use. So the price for this one is 1700. So this is also a adjustable voltage only protector. So similarly, you have another device wherein you have the voltage as well as the current, both are there. So this is from Euro controls. So this is again 63 amperes and this is 1439 rupees. So you can use this one as well. This is again another device. This doesn't has a LED panel but a LCD panel. So this is little bit costly, 1790. So all the devices comes in this particular range. So this is again a quick sense. Similarly, so there are multiple brands. After all, like we need to understand one thing, that all the circuits and all the components which are used inside, those are completely imported from other countries and only assembled in India and are being sold. So it doesn't matter on the brand or the logo that you are buying. This is not manufactured in India, and this is simply just purchased from outside different countries like China, and it is just assembled in India and is sold. So this is the one exactly what I bought from the next gen. The looks might little bit differ, rest all the functionalities are the same. Similarly, Amish Smart, this is also similar looking device. The cost is little bit high, that's it. So any device that you wish, you can directly buy. Only just look for the features, that such kind of devices doesn't offer you setting of the panels or the setting of the voltages, delays, etc. So if you just go on a little bit higher cost, so this offers you like adjustments and setting. So it is clearly written like adjustable setting. So you just, before purchasing, just go it through thoroughly, like whether it allows setting or not. That's it. So this is the product I received from Amazon. This is it. Let's do a quick unboxing and see how's the product. A very tiny one, very small. Let me give you a size comparison. So it's almost 3.5 inches, 1.5 inches, and 3 inches. So this is the packaging size. Let's see what's inside. That's it. This is also pretty same in size. Now let me create the setup and we will test. Hello guys, so now I will be showing you the setup which I made. So this is the power. This power is coming inside a variac. So this is a AC voltage changer. So the knob that you see here, so if I rotate this knob, so this will lower down the voltage. If you can see in the voltmeter, if I increase it, it will increase the voltage. So this is a linear AC voltage regulator. We call it a variac. So this is a homemade setup that I have already made for multiple different testing purposes. So I will be using this particular setup to test this particular item, the voltage protector, to check whether this particular voltage levels are set properly or not, whether it is tripping in low voltage, high voltage, as well as for overcurrent, etc. And along with that, I will be, just because this particular device shows you the voltage, so I need to do a tally comparison whether the voltage and the current which is being shown over there is accurate or not. So for that purpose, I have a reference multimeter over here. So if you see, like I have set the multimeter into 600 AC voltage range. So from here I set it to AC. This is the 600 voltage range and I have power it on. So the voltage and the common, I have both the terminals using which I will be checking it. And along with that, what I did, this is my output from the variac. This output is getting inside this particular power controller or the voltage protector, and from this the output is going to this particular load board. So this is nothing but a loading board in which I have different bulbs attached, and if I power on this bulb, automatically the load would start increasing. So for this I will be increasing the current so as to mock the scenario wherein the load will increase and automatically the trip down will happen. So for your glimpse, right now if you see, if I just turn this on, so 0.07, so 700 milliamperes current is being taken. If I power one more bulb, the current will increase 1.1. If I power on one more, it will go to 1.5. So I have set the limit of 1.6 amperes as my current maximum limit. So you can go to 63 amperes. So for that, as soon as I will turn on the fifth bulb, it will cross 1.6 and automatically trip down will happen. Let's see. You see, it automatically tripped down and a countdown began that it will automatically reset after 10 seconds. So it will again check if after 10 seconds also the load is more, it will again trip it down. So this is how this device works. So now I will be showing you an exact glimpse of how the entire thing is to be set up and how you can do the setup at your home. So now I have with me the manual that has been provided with this device. So it clearly says like how the setup of this particular device has to be done. So if you want to take it as a reference, you can pause the video and see. So now I will begin the setup. So you need to press the set key for 3 seconds. As soon as it crosses 3 seconds, A1. So A1 is your power on delay, that how much time will it take to power on the device once the electricity is resumed. So let's assume I set it to 10 seconds or 15 seconds. So as soon as the power comes on, after 15 seconds, it will supply the power. A2 is your maximum voltage limit, the high voltage. So for example, I set it to, let's assume 225 volts. So as soon as it crosses 225, it will trip. A3 is your lower threshold voltage on which it will resume the power. For example, high voltage happened at 225. So as soon as it crosses again 220, it will turn on. So 225 and there is a 5 volts gap. I set it at 220. A4 is the response delay time, that for how much time it will trip it off. So let's assume, as soon as a high voltage happens, it will trip down this device for 10 seconds. This is the response time for the high voltage cutoff, that how much time will it monitor before tripping it off. So you should keep it as minimal as possible, just because to safeguard your devices, you cannot allow the high voltage to go into your devices for a longer time. So I have kept it to 0.1 seconds. This is your low voltage cutoff. So as soon as the voltage goes below 160, it will automatically again trip off. For A7, as soon as the voltage crosses 165, that means the lower voltage is gone. Now again the voltage is coming to be optimum. It will again turn on. Similarly, you have a delay time for your lower cutoff, that it will monitor for 10 seconds that it has crossed 165. Now it is not lower voltage and it will turn it on. This is your response time. So for how much time will it monitor for a low voltage? Let's assume it crossed 160. So do you want your device to run for 5 seconds and then trip off? No, not at all, because like lower voltage again might damage your devices. So keep it minimum. A10. This is setting the maximum current limit. So this device, I have set it to 1.6 amperes. So if you increase it or if you decrease it using the plus minus button, you can do. So let's assume I set it to 1.6 amperes. So as soon as it crosses 1.6, automatically the device will trip. Similarly, it is again your delay time for the current, that as soon as the current overload happens, for how much time will this device trip off. So it will turn off for 10 seconds. Then again it will check if the current has gone down. If yes, it will power on the bulbs. If no, then again trip off. So like that. A12 again is your response time. So as soon as the current goes over, so automatically it will respond within 0.1 second and trip it off. Now A13 is your voltage calibration. What is this voltage calibration? For example, your device shows 183 volts, but actually it is 185 volts. So there is a 2 volt difference. So you can set it to plus or minus. You can adjust it accordingly. So I have adjusted it to minus 1.5 to calibrate the exact voltage. So I tallied it with the multimeter. Similarly, A14 is your continuous overcurrent fault times. For example, like if your overcurrent or the short circuit happens for repeated number of times, so how much time you need to keep it off. And A15 is like finally your current calibration. If you are seeing like your device is not showing the exact current, then you can set it or calibrate it. You can make it plus or minus as if you need. So that is not a problem. So for me, it is quite accurate and I set it to 0. As soon as you hit, so this is the end of the setup and all your details are saved. That's it. So your device will reboot once you have saved it everything, and automatically it will be set and your device will be ready to be used. So now you see there are 4 LEDs over here. If you take a close look, so this is the normal power LED, this is the overcurrent LED, this is the under voltage LED, and this is the over voltage LED. Based on your current electricity supply, if it is over voltage, it will trip and this particular LED will glow to indicate that your current supply has been disrupted just because the voltage has crossed your upper limit. If it is lower voltage, this LED will glow and it will trip it off. If your current is high or overloading happened, this LED will glow and it will trip it off. So this is a very simple setup of this device. So hope like you understood this one. Now what I'll do a voltage calibration check whether my device is accurate or not. So I have my multimeter with me. So as you see, this device is showing 203 volts and you just checked like I have set minus 1.5 to make the voltage calibration according to my this multimeter. So now let's see what is the voltage. So I just place the terminals over there. You see it's quite accurate. 203 is shown in this particular device and 202 in my multimeter. It's 203. That's it. So the voltage calibration is done. Similarly, you can do a current calibration as well, the way I told you. Similarly, you need to just connect these two probes in series and do the current calculation. So now let's do a runtime check. So how? Let's assume like I am turning on one bulb. So this is my load. I turned on 3 bulbs. So you see 1.1 amperes load is being taken. What I will now do is like I will increase the load to increase the current and see if trip off is happening. So I turned on the 4th bulb. So you see 1.5 and you guys have seen like I have set the maximum current limit to 1.6 amperes. So now as soon as I will on power on the 5th bulb, it will automatically trip. You see, it automatically got tripped. And I set it to 10 seconds as your delay time to check again if the power has been or the short circuit is there or not. So you see again it tripped off and again the countdown started. So you can change this delay from settings. If you want to keep it off for 30 seconds, 1 minute, you can do it. So I'll turn it off 2 bulbs to again reduce down the load so that the current falls below 1.6 amperes. You see now the current is below 1.6 and it continuously turns on. Now let me show you a over voltage check. And just I forgot to mention, like as soon as I increase the current, you will see this particular LED will glow saying that this device has tripped due to overcurrent. You see this particular LED is glowing due to overcurrent. So now our next text will be to increase the voltage and have a check. So using this variac, I'll slowly increase the voltage. You see the voltage is increasing. As soon as it goes above 230, it automatically trips down and says HV, high voltage, and this particular LED starts glowing. So this is how this particular device will safeguard your precious appliances from getting damaged from the voltage fluctuations at home. Definitely you all understand that you won't be using stabilizers at your home for every devices, right? People generally use stabilizers for their TV, washing machine or fridge, but nobody tries to use a stabilizer for an induction cooker or a microwave oven or like for geysers. But those are also heavy appliances, right? Those devices can also get damaged. So how do you prevent from having those damages? So this is how this device can protect you. So now if I again reduce down the voltage, and as soon as it goes below 225, again a 10-second countdown will begin, and automatically it will start resuming the voltage. You see, the 10-second countdown started. Just because the voltage from high voltage has dropped to a normal one, it will again turn it on. You see, it turned on. So now let's again do a check for the low voltage. Now I will reduce to the low voltage. You know, like I have set the limit to 160 volts. So now let's reduce it down to 160 and see what happens. You see, as soon as the low voltage happened, right now the voltage is 159, and it is clearly saying that it is low voltage trip off, and it says LV, low voltage, and it tripped off your appliances from getting damaged. So again, it has a resuming voltage. So it's set to 165. If I increase the voltage to 165, again a 10-second countdown will start and it will power on the device. You see, the 10-second countdown started. As soon as the 10 seconds are over, it will start. You see, so simple. So this is a very valuable instrument. You can add it to your home to safeguard the appliances that you use. And if you see, like, this is the normal power on. Now the interesting part is, for example, you are going out of home and you need to cut down the entire power. So you have a power on off button over here. If you just simply press it, it will turn off everything. It's off now. If you again press it, it will power on everything. So this can act as a main switch as well. So you need not worry about. So all in one package inside this single device is being offered. So this is in a nutshell how this device functions and works. So it's very simple. I'll just show you a close look of this device so that you get a deeper understanding. You see, it's input. So line and neutral will be input for this device from the top. And if you go down, you will see it's showing output. So this is your output from which line and neutral will be out. So this device you need to connect in series with your appliances. That means the main power input, when it comes automatically, you just simply need to connect it in series. So this is in short the entire video to understand like how this device functions and whether it functions pretty well or not. So I think like you got a clear understanding how this device works and everything. And as I showed you, like this device comes with this user manual. You can easily refer this user manual. Everything is written properly. And this is a very robust device. I have opened it up and have seen like how this device has been manufactured. The quality of the components are very good as well. So you can rely on this device. And the very important thing is like the size of this device is equivalent to 2 MCBs. So you can directly connect it to your MCB box as well. So for example, if you have 2 MCBs and 2 positions are vacant, you can simply plug this particular device with the MCB slot as well. If you see this particular connector, this one, so this is your MCB connector. So just need to push it in the rail and just lock the device like this. That's it. So for fixation purpose also you need not worry about. So all the fixing mechanisms is there, and you have the screw terminals over there. The screw terminals are very robust and the wires get affixed very properly. So nothing to worry about. This is a very good device that I would suggest like everybody you should use at your home, because like like today the appliances that we use are very costly, and like if those get damaged, definitely the service center tells you like the motherboard has burnt down and you need to pay 10,000 rupees for a single motherboard and all. So if you want to avoid such kind of disruptions and like unnecessary wastage of money, I think like this is very wise to use this particular device for your entire home. And the surprising thing is like this particular device comes with 63 amperes. So this is the the box that I have received. So this is 63 amperes, This is the particular protector device that I got. And 63 amperes means like you can give entire load of your house. The normal buildings that we have, like generally two-storied buildings, so 63 amperes is huge. Like a AC takes only around 8 to 10 amperes, a single AC. A 1.5 ton AC will take almost around 10 amperes. So if you have two ACs, it's 20 amperes. A induction cooker takes almost around 6 amperes. A compressor pump takes almost around 7 amperes. So altogether, if you sum it up, like it will never cross 63 in general conditions. So you can use this one device for your entire home. So this is in short, like I guess you liked the video and hopefully this is very informative for you. So this is just a educational video for you to help you guys like from not getting your devices damaged. So if you like this video, do try to implement it at your home. Thank you.